This Sophia Turbojet promotional and instructional film is from the archives of Model Engine Corporation of America. It is not to be copied or duplicated in whole or part without written permission. It was originally released in 1996 and was filmed on VHS tape at the Mikowa factory in Monrovia, California, and on location at the AMA Flying Fields in Muncie, Indiana. Bear in mind, this was when model turbojets were in their infancy.
Forget the ducted fan, now you can have the real thing, a real turbojet engine from Sophia, USA, producing 12 pounds of thrust at 123,000 RPMs. This true turbojet engine will power a jet model with such realism you won't believe your eyes or your ears. This is the entire airborne package for the Sophia. A standard fuel tank, oil tank, fuel pump, digital speed controller, and battery pack are all that's needed in your aircraft. Before the fuel reaches the inlet block on the engine, it is fed through the anti-siphon valve, T-fitting, and fuel filter. The turbine-type fuel pump is controlled by a digital speed controller, which is powered by a 12-volt battery pack. Pressure is taken off the compressor stage of the engine and used to pressurize the oil tank. The oil is then fed to the inlet block of the engine, to the bearings, and burned in the combustion chamber. A spark generator is used to initiate combustion. This included with the total package. An air nozzle and trigger used for starting are also included. This will be connected to your scuba tank and regulator. Two gauges reading compressor pressure and fuel pressure are included. These attach to the T-fittings with quick disconnect couplings. The complete running package includes all that's seen here. Mounted on the test stand, we have our fuel tank, supplying the fuel pump, which is controlled by a digital speed controller. The fuel pump is being powered by a 10-cell 1400 milliamp battery. Fuel is fed through the fuel filter to a T-fitting with pressure gauge so we can determine running conditions of the engine. Next is the anti-siphon valve, which keeps fuel from siphoning into the engine from the fuel tank. Without this, the engine will fill with fuel and create an unsafe and dangerous condition. The pressure gauge gives us the starting pressure, 1 kilogram or 14 psi, idle pressure, 0.3 kilogram or 4 psi, and full throttle pressure, 2.8 kilogram or 41 psi. Compressor pressure is fed to the oil tank and is also monitored in our compressor pressure gauge. Compressor pressure will range from 0.3 at idle to 1.3 kilograms at full throttle. Oil is then fed to the engine. The spark unit generates a continuous spark to initiate combustion. Once combustion starts, it is self-generating and spark unit can be removed. A compressed air line is attached to the engine and used to spin the turbine up to starting speed, usually around 15 to 20,000 RPMs. This requires about 125 psi. Our test stand has instruments to read thrust in kilograms. 1 kilogram equals 2.2 pounds, so a reading of 5 kilograms in this meter equals 11 pounds of thrust. The exhaust gas temperature is read in centigrade scale here. 700 degrees centigrade equals about 1100 degrees Fahrenheit. Fuel pressure and compressor pressure determine the maximum and minimum power outputs of the engine. These are the most important readings and should be monitored closely. The RPM gauge is used to confirm all systems are relating correctly. 2.8 kilograms of fuel pressure and 1.3 of compressor pressure will be producing 12 pounds of thrust. The Sophia requires white gas, kerosene, and turbojet oil for each run. Before the first run, we must set up the fuel pump speed controller. This is done by holding the jet over a pan and adjusting the transmitter with the speed controller. Low speed idle setting is 0.3 kilograms and maximum throttle setting is 2.8 kilograms. This must be set accurately as these pressures determine reliable running conditions for the engine. Starting pressure is 1.0, and this you must reference on your transmitter. The fuel mix is anywhere from 50-50, white gas and kerosene, to as much as 90% white gas. Today, we will be using about 30% kerosene and 70% white gas. The hotter the weather, the lower percentage of white gas. White gas, or better known as Coleman lantern fuel, improves idling characteristics and starting ability. White gas is similar to gasoline and is extremely flammable and dangerous, so extra care must be taken at all times. It is also important to have a fire extinguisher close by. The oil tank must be filled before each run using the same oil as a real turbojet. Do not use a substitute. The J450 has a total loss oiling system, which means after the oil has lubricated the bearings, it is burned and lost forever. It is very important that only turbojet oil, like Exxon 2380, be used. This is a synthetic oil and is designed to take the extreme temperatures inside the turbojet engine. Before starting at the beginning of the day, the bearings must be primed with oil to avoid any dry running. Dry running will ruin the bearings immediately and must be avoided. The Sophia package includes quick disconnect couplers for convenient operation.
Our Sophia engine. I'm going to hook up the spark unit. One lead goes to a grounding point on the engine, the other to the spark plug. Turn on the main switch of the ignition unit. Hook up our compressed air, which is usually supplied from a scuba tank. And this will spin the compressor impeller up to around 15 to 20,000 RPMs. First I'm going to apply the air pressure, then the spark, and then turn on my fuel pump. It always has to be done in this order. After the engine starts, I'm going to continue to feed air pressure until I get 0.3 kilograms of compressor pressure. Then I can disconnect the air and the spark. All throttle adjustments must be made slower than normally with a turbojet engine.
The engine is easily stopped by cutting power to the fuel pump. Now you can see the test flight of our 747-400 powered by two Sophia J450s. This 747 weighs in at about 45 pounds with a 10-foot wingspan. Total cost is around $26,000.
into the wind. I'll be quiet from here on and let's listen to it.
All right.
Stacking, okay, looks like he's coming around into the wind. I'll be quiet from here on and let's listen to it.
Same great.
Randy ought to be real proud of Mr. Oakey also.
He has put the gear down.
Larry, I'm telling you, her and I pick it up for one end up. Tell me. I think you pick the heavy end up so now he's got all kinds of beautiful. Thank you. Out of Tokyo, Japan, Mr. Oakey with a beautiful 747. We've got the same car alarm going off out the back, out in the parking lot. We'd really like to ask you guys, gentlemen, not to reset your car alarms because it's just causing so much havoc back there that nobody can hear you. So I realize the one on the left is out there. Let's have a nice round of applause for Mr. Oakey. He's just done a beautiful job for us. Hey, there we go.
Folks, I hate to rain on you parade, but I need everybody.
there. Oh, I hope it's here tomorrow and we get some more tape recorders. This is just beautiful. Let's put it together one more time for him, okay? Let's give a nice round of applause to him. Thank you very much.